Hi guys, today let's look at the link code number 2, trailing zeros. Let's look at this description to see what it is. So this problem actually asks us to write a function, write a algorithm which computes the number of trailing zeros in n factorial. So what does it mean? Let's look at this example. n 11's factorial is this number. And in this number, we have 2 trailing zeros. So the algorithm is going to just return 2. So that's what it means. The really challenging part is this. We have to calculate this in O log n time. This is really challenging. If we don't have this challenge, we have some easier ways to do it. We just simply calculate the results of n's factorial, and we started from the end, count the zeros towards to the left until we met the first non-zero, and the whole algorithm just stop. But there are some issues. The first is that it's quite dummy, and it takes a lot of computation power to calculate the n's factorial, because the number is going to be super huge. And also, if you use Java or some other languages, the number is has a limitation of its bit, like 32-bit or 64-bit. It has a limitation, so it's extremely that it's gonna just overflow. But if you use Python, I think Python is fun, because in Python you can just use the number to represent arbitrary lengths of the integer. But still, it's not a good way, because it's too complicated. So let's think of how we just implement it using O log n time. Actually, in this case, we actually have to think how this zero, generated. And if we just, analyze this, and we realize that it's all related to n's factors, n's factorial factors. Only when we have the 5, I have a lot of notes, but it's there in Chinese. Only when we have the 2 multiplied by 5, then we have zeros, right? But before, you have to understand what does it mean when we calculate the n's factorial. So the rules is that we have to let me just write it down. So n's factorial, actually it is calculated in this way: n multiplied by n minus 1, and multiplied by n minus 2, and just multiply by all the way to the 1. So that's how we calculate the n's factorial. So it all depends on that. This is one factor, this is one factor, and this can also be have multiple factors. So we realize that it all depends on how many factor of 2 and how many factors of 5 you have. When you have one pair of 5 and 2, you got 1 0. If you got multiple pair of 5 and 2, you got multiple 0. So the pairs of 2 and 5 of n's factors give us the answer how many trailing zeros we will have. And also, this is the number 1. And number 2 is that we realize that 2's number, factor 2's number is always greater than 5's number. So so we just only need to calculate how many factorials of 5 in n's factorial. How many factor 5 in n's factorial? Then we get our answer. For example, let's look at the 28 factorial, and we can see that we have like 5, 10, 15, 20, and 25 as its factorial. And in this case, how many 5 do we have? We have 1 5, 5 multiplied by 1, and 10 is 5 multiplied by 2, and 15, 5 multiplied by 3, and 25 multiplied by 4, and 25, 5 multiplied by 5. So after we do this, we realize that how many 5 factor the 28 factorial contains. We can see 1, 2, 3, 4, 5, and 6. We have 6. So by looking at this 5, 10, 15, 20, 25, this is 4, right? So this is 5. So how can we get this number? Actually, it's just this formula, floor n divided by 5, then we get this 5. But also, when we have like 25 factor, it actually contains 2 factor of 5. So we also have to do this n divided by 25. If it is n is larger, then we have to divide it by 25 multiplied by 5, which is n divided by 25. All the way goes on. So in the end, we actually develop this formula. The answer of this trillion zeros actually equals to floor n divided by 5 plus floor n divided by 25, and go on. So this is the whole thing. Now, this is the analysis part. Let's look at this solution. I use Python, and trillion zeros, this is our function, the entrance, and we're taking one parameter, which is the n. And first we give the factor the initial value of 5, and we give the answer 0, and we have the while loop. If this n greater than our factors, we're going to just continue doing this, n divided by the factor, and we get the answer. And here we just accumulate the previous answer. And after this is done, we're going to just calculate the we just update the factor by multiply it by 5, and we continue until the factor is greater than n, and the whole while just exit, and we return the answer. Actually, it's just this formula. So let's run this to see how it works. And okay, it's working fine. And also, let's analyze this time complexity. The whole time complexity actually depends on how many times we calculate by this part. Actually, it's just the log. The base is 5, and n, and log 25 comma n, log 125. Actually, each part is O logging. So eventually, the algorithm complexity is n log n. Yeah. All right. Thanks. Today this is our algorithm. Bye bye.